Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us here for this webinar on Kubernetes backup and recovery. We're putting a bit of a spin on the traditional backup topic because we're talking about not just Kubernetes backups, but Kubernetes backups when VMs are in the mix. I've got two wonderful presenters for you here today. We've got Jesse, one of our senior solution architects here at Spectro Cloud, and we're joined by Martin, field CTO of CloudCasa. They are a backup vendor. We have some wonderful slides for us to go through, whistle-stop tour, and then we've got a live demo at the end of this webinar. So wish us luck with the demo gods. We've also got some real-world stories here. This is not just solution description. We've had a great example of working together on an enterprise customer, and we're going to share all the gory details. We're going to be following up with a couple of emails if you've attended this. So there are some resources that we talk about through this session. You will have a copy of those. Jesse, over to you. Take it away, sir.
All right. Thank you very much, Ant. Welcome all. We are very excited to have you on our joint webinar. Today, we will discuss how Spectro Cloud and CloudCasa technologies complement each other's application stack around backup and recovery for VMs and Kubernetes. We'll wrap up with a live demo showcasing deployment, backup and recovery for both containers and virtual machines, so you leave with a clear, actionable strategies you can use in your Kubernetes environment. All right, let's do some intros. So I'm Jesse Benoit. I'm a senior solutions architect. I've been here with Spectro Cloud a little over 4 years. I'm very happy to introduce my friend and fellow host, Martin. Martin, can you please introduce yourself to our audience?
Yep. Thank you, Jesse. Hi, everyone. My name is Martin Fahn, and I'm a field CTO here at CloudCasa by CalLogic Software. And we've been in the business of backup and data recovery for nearly 3 decades now. So from when backup consisted of tape libraries and people backing up their own files by copying them to separate disks or files. And we've changed that to a more centralized data protection or backup approach, acting as a catalog for all your backups wherever they might be located, hence the name CalLogic Software. But Kubernetes certainly changed how we approach backup from a container perspective, and I'm glad to be here to discuss how we've continued to provide this evolution of protecting containerized VMs in Spectro Cloud.
Oh, thank you very much, Martin. And yeah, just to hammer home what Martin said, our goal today is to spend some time to talk with you and just discuss how best to back up your VMs and provide protection in your Kubernetes clusters. All right. So a little quick note about my company and our background. Spectro was co-founded in 2019, and our mission, simply put, is to help organizations simplify their IT infrastructure. And we want to enable companies to unlock innovation at scale. And we believe that a critical enabler for this mission is Kubernetes, and our teams are committed to helping businesses realize its true potential. And that means not only deploying Kubernetes, but also the VMs that are associated with that application stack. Palette is our enterprise Kubernetes management platform, and that allows companies to control the full Kubernetes and VM lifecycle, no matter where they are, across clouds, data centers, bare metal, and edge environments. Today, we'll do a quick hands-on dive into building rock-solid resilience for your Kubernetes environments in your VMs. And in terms of data protection, I could think of no one better to collaborate with than CloudCasa and CalLogic, who've been in the data protection game for longer than my career, over 25 years at this point. Martin, can you add a little color on CalLogic and CloudCasa?
Yeah, absolutely. So we knew that the landscape for data protection would be changing when Kubernetes was created. So we had implemented CloudCasa in order to move forward with that evolution. And in ways in which you should think about how CloudCasa protects Kubernetes, we're no longer looking at that agent-based or even agentless approach. It's going to be more of a backup of stateful data that you should be considering. And now that more users are moving their infrastructure to cloud native workloads like containerized workloads like containerized VMs, CloudCasa will be right there to protect those workloads.
Oh, very good. Very good. All right. So, quickly, let's take a look at kind of the evolution of infrastructure and apps. There's been a real, we talked a second time I've used the word 25 years in my career. And if you look at the evolution of infrastructure and apps over that time, it's quite astounding. First and foremost, we had the traditional physical servers, now commonly called bare metal servers. And then, there was a real game changer, with virtualization. And then, of course, we have the hyperscaler and now containers and pods. And through that evolution, it's not like the standard evolution that you might remember from science class. The Neanderthal is still running around with the humans, so you have to account for all. So the solutions that we'll talk about today will show you how to specifically back up those containers and also those virtual machines in that that data center of everything, where everything has evolved but is still around. We're going to talk about the final use case here, but real quickly, you can use Spectro Cloud Palette for I kind of call Spectro Cloud Palette the Swiss Army knife in a tool set. And I would say our four main tools or blades in that Swiss Army knife are what you see on the screen. So Kubernetes as a service is all about standardizing how platform engineers and IT ops serve developers across their environments and be consistent across multiple clusters and distributions, and depending upon the app requirements and use case. Bare metal is all about increased performance and optimizing the cost and efficiency for specific apps. And you can also eliminate the hypervisor tax when you're deploying right into bare metal. Edge is truly transforming my business, our company. If you look at the hits on our website and our revenue generating activities, Edge is a big leader in what we do. And while those three use cases are really great and important to talk about, I'd love to do that another day. But what we're going to focus on today is unified container and VM management. As organizations look to have an alternate for VMware or to be able to move their legacy VM workloads alongside containers, this is a solution that we have. Okay, I thought we'd take a moment. If you can think in your own time, many of you that probably signed up for this webinar have had or have responsibilities for backup and restores. And I thought it'd be a good idea to, for one of you guys to come up and name a horror story of backup and restores. But I'll go first. I remember back in the day, I was promoted from help desk to server admin during my first few years of my career. I was becoming a big deal in my mind. They put me in charge of backups for a company in about 5 company sites in the US. I think we had about over 100 sites worldwide. And we used tape mostly. And I and local site admins changed a lot of tapes at these sites. It was mundane and monotonous work until it got exciting real quick. I remember 1.5 terabyte of data we backed up once or twice the tape each quarter. And then I ran an incremental robocopy job that I scheduled from a file server to another server to act as a scheduled job to ensure that the data was backed up every night. While away on business travel, the head of development told me she accidentally erased the data and needed to restore from the night before. Then and only then did I learn my robocopy job had failed a month earlier. I realized it was my fault and we had no backup in recent times because my scheduled job failed, and I had to tell her, OMG. As they debated firing me, I could not believe how terrible my backup had been. This appeared a fireable offense, but they left me off easy. And that is kind of the genesis of, I thought a story I'd share and how important and crucial it is for you to have, good backups and good disaster recovery strategy.
Yeah, absolutely, Jesse. And while I don't have any personal horror stories of my own, I've been on the receiving end of that frantic phone call from customers that need their data back ASAP. And I can certainly appreciate the sudden hard drop where you think that your data is potentially gone forever. And luckily, we've been able to help them recover their data. But I think that users and customers understand the benefits of a commercial solution and the need to grow from that homegrown or open source solution that may or may not be able to do what they need to do, especially in the area of virtual machines. And virtual machines is going to be a big part of that as users now look to containerize their VMs or move off of hypervisor VM deployments to Kubernetes and Spectro Cloud VMO. So they'll need a data protection solution in place when they perform this type of migration.
Absolutely. Whether it's an admin error like that or, something more pervasive like an attack from, criminal groups operating for ransomware reasons that are attacking your infrastructure. Having a good enterprise-grade backup solution is going to be key. If you are hacked and you have 1,000 servers or 1,000 VMs that are backed up, you also want to consider how many VMs can you back up in a day. With using products like a CloudCasa, they're really going to enable you to react to human error and, of course, malware or any ransomware. All right. So, users moving away from traditional hypervisors are looking for options to host virtual machines. We're out there all day long, and many of you have heard, I meet 2 kinds of customers. they kind of slam their fist on the table and say, hey, I no longer want to pay Broadcom any money whatsoever. And then the rubber meets the road, and they talk to their engineers, and they realize that maybe they can't get off of VMware so quick, so they want to decrease their footprint. So they start to look at solutions that, and we want a virtual machine orchestrator to be that solution. As you start to look at the options out there, whether it be Nutanix or OpenShift virtualization or Red Hat virtualization or Proxmox, we really believe that our product is the best in breed out there. In fact, first off and foremost, for my VMware fans out there, I'm a former VCP. Our solution works great with VMware, like a lot of solutions out there in the commercial and government space. There's some competition. So while many of our customers are deploying to VMware, many of them are trying to get off of Tanzu. Many of them are trying to get off of the expensive hypervisor, and that's what we can do. And when they do that, the people that we meet, they're trying to decrease that Broadcom bill. They're trying to host VMs and containers side by side. Oftentimes people first put their foot in, we love the customers that are deep into containerization and virtual machines. But a lot of customers find out that, maybe 20 key applications, revenue generating applications that they have in their data center, the next version might be containerized. So that's where, they start to look at solutions that can offer both containerization and virtualization all from the same portal. And if you're leaving VMware as a former VMware admin and now 4 years into the Kubernetes space, it's not a simple transition to become from a vSphere administrator to a Kubernetes administrator. There's a lot of toil and effort on behalf of the organization to be able to do that. And so with our solution, we really believe we take that onus off of the customer and put it on our software. And then, the key thing, the application portability. They want to be able to repatriate from the cloud to on-premise, and sometimes from on-premises to the cloud. And they still have legacy virtual machines at the edge in the data center that they need to keep. So here's a simple diagram kind of maybe some open source technologies and also our IP and commercial off-the-shelf solutions. And this is one reference architecture that we use. And in fact, I think I mentioned it earlier, 90 to 95% feature parity we can provide when you compare us, Virtual Machine Orchestrator, to vSphere and vSphere Enterprise Plus and vCenter. As you can see, there's a lot of the different technologies. And later in the webinar, we'll show you a running VMO cluster as part of our VM backup and recovery demonstration. For more on CloudCasa, I'll let Martin dive in and tell us a little bit about his solution and what they can do for us.
Yeah, I appreciate it. Thank you, Jesse. So I already introduced myself. Let's get to the next slide there, Jesse. And we're just going to start with the foundations of Kubernetes backup, disaster recovery, and compliance, and then explore some of the real-world pitfalls that either simple snapshots or open source solutions like Velero can miss. One thing that you should know is that CloudCasa is a service, but it can also be self-hosted. So it's built in Kubernetes for Kubernetes to help you protect and migrate and replicate your Kubernetes environments, anything from stateful workloads to virtual machines running on Spectro Cloud VMO or KubeVirt or SUSE Rancher virtualization or OpenShift virtualization, et cetera. And we can perform granular recovery of these resources, anything from single files from within PVCs, or help users migrate resources from like VMs from on-prem into the cloud. And one thing that we are known for is that we are the most cost-effective solution for Kubernetes data protection on the market today. And this is going to be especially helpful, especially for those users that are looking to move towards containerized VM architecture in VMO, because instead of being licensed by capacity base or per VM, the way CloudCasa is licensed is actually per workload. So regardless of the types of VMs you're spinning up or tearing down, we only care about the underlying count of Kubernetes workloads on which these VMs live. So customers can oftentimes end up saving money on the DR and backup strategy when they are making this shift to a hypervisor-based deployment or to a KubeVirt from a hypervisor-based deployment to containerized virtual machine-based deployment.
Absolutely, we're big fans. I remember when we first met, recent customer, or a customer win. I think they were moving from like 50 different clusters in Tanzu, and one of those customers was really anxious to get away from Broadcom billing, and they looked at Cas and Veeam, and they looked at you guys, and you guys were the clear winner. So we're very proud to partner with you and CloudCasa to handle the backups for that key customer of ours. So
cool. Absolutely, that was a good win. Yes.
Yeah. So let's talk a little bit about Palette today. First of all, and we'll show this in the demonstration. We're going to get into how we're going to deploy a virtual machine cluster and back it up. But I just want to highlight some of the things that we believe are value adds for our solution. First of all, we have a distributed architecture. So if you're deploying Kubernetes clusters, some of our competitors like Rancher have a concept of a management server that needs to sit in the way. So conceivably, they can only run a few hundred clusters before they have bottlenecks. And if that management server goes down, then that cluster is down. So that leads to designing highly available and redundant management servers. With us, we completely flip that around. We push all of the management monitoring and performance tuning straight to the cluster. So we've tested and actually been able to deploy over 40,000 nodes and 10,000 clusters simply because of that distributed architecture. Now, the diagram on the left, when you deploy Spectro Cloud Palette, you'll have this we use this technology called cluster profiles, which basically acts like a blueprint to say this is what a perfect cluster looks like. And that's where CloudCasa sits in. Martin, maybe we want to mention kind of how we use CloudCasa in that stack on the left in number 2 to deploy.
Yeah, absolutely. So that's exactly where we slot in. That's where we'll have our pack-based deployment. So as Jesse will explain during his demo, everything, clusters, virtual machines, they can all be created by specifying a profile, and CloudCasa can be a part of that profile as an added pack. This is something that users can download directly from the Spectro Cloud Community Registry. They'll download the CloudCasa chart, and from here they can specify a cluster ID that they would define in CloudCasa to install the agent, but manage it all from Palette itself. So the whole entire lifecycle of the backup agent installation can be managed by Palette.
Absolutely, and those layers, those stacks are real critical. Each layer in there has a different upgrade process, just different critical vulnerabilities, and which leads me into the third point on the screen is that what we call day 2 operations. Day 0 is you design, build this cluster blueprint, what a perfect cluster looks like. Day 2 is you hit the deploy button, but then that period from deployment to the end of the life of that cluster is crucial. Some of you may remember about 10 months ago, the Ingress nightmare or the Nginx nightmare, where Nginx had a critical vulnerability rated 9.8 out of 10. And I remember reading a newspaper article at the time that it was going to be very hard for people to identify where this vulnerability existed and patched it. And I kind of gave myself a virtual pat on the back, because here at Spectro Cloud, that's exactly what we do. We can identify any critical vulnerabilities in your stack, including Nginx, including if anything happens with CloudCasa, and be able to upgrade those different versions. Not only that, but we offer curated stacks. Think of bumper bowling or bumper pool, where there's no way you can scratch, there's no way you can throw a gutter ball, because we know what all those different components, which ones work together, which ones don't. For example, as new Kubernetes features are released, certain features are deprecated, certain features are added, and that will only work with certain operating systems and certain versions of the application. So a Spectro Cloud kind of manages all that. And then, of course, we can do that in any environment. But today, we're going to specifically be focusing on that day 2 operations, specifically backups. Okay, so Martin, I think maybe we'll dive into Palette a little bit and get into the demo.
Yeah, sounds good.
Right here, let me just bring up my screen here. All right, screen. Oh, look, mirrors, 1,000 mirrors. Don't look at that. Okay, so here is our Spectro Cloud interface here. Let me quickly give you a quick tour. When you first log in, you can do single sign-on. So any identity provider that you use can be used to access the Spectro Cloud Palette. We deploy software as a service. We also deploy self-hosted. Self-hosted could be deployed to your VMware cluster. It could be deployed to your Real Metal solution. It could be deployed to your GKE, EKS, or AKS cluster. Wherever you have a running Kubernetes cluster, you can deploy Spectro Cloud Palette. And then also, I should mention, we have a very unique group of customers here. And in this space, about 40% of our customers are actually government. Think three-letter agencies. And a lot of those agencies and government agencies need to deploy in a completely air-gapped or internet-free environment. So just know that you can deploy Palette in any number of those ways. Quick view of the portal while I got you here. Administrators, tenant admins, like I'm logged in, can come in and easily set up their cloud accounts, whether it's to VMware, AWS, EKS, or Real Metal. We can integrate with single sign-on, registration tokens, a lot of wonderful bells and whistles that we use to secure and manage the environment. But let's first go to a concept of projects we have. So let me show you a running virtual machine cluster. So here in this cluster, and actually I'll come and deploy another cluster in a moment, but I first want to show you a real metal cluster that we have deployed. Here we have these stacks that are cluster profiles that are available right out of the box that you can use to deploy your cluster. And that will allow you to, hold on, get a little slowness here. Okay, so you see on my left are all the different components of the cluster. You remember that reference architecture designed some of these technologies that are deployed there are deployed here. And then if you look at the nodes here, running over my phone Wi-Fi here, so it's a little slow. You see we've deployed the control plane and worker pools, and the worker pools will host containers and virtual machines. I'll bring up that virtual machines tab here. But while we do that, let's quickly spin up another cluster. Show you how easy it is. So here I'll go to my training VMO, and we'll deploy a cluster. I'll double click on, for sake of, I'm out of bare metal machine, so I'll actually deploy into Azure just for demonstration purposes. Of course, in the real world, if you're looking for virtual machines in Azure, you would just use their infrastructure as a service to deploy those. If you were in Amazon or GCP, same. But for demonstration purposes, since I don't have any real metal nodes, I'll deploy it here virtually first. So it's easy as just clicking on the infrastructure button and then hitting deploy. And here you'll be asked for some specific information. We'll call it CloudCasa Demo 1. Choose my account. All right, and now add a couple of complementary solutions. Here's our CloudCasa backup. Here is some core components that I'll also need, and some templates for servers that we can deploy.
And these would be the packs in the profile, right? From a
exactly right.
Perspective. Yep.
And I think we also, so here when we deploy the CloudCasa pack, we'll see some variables here, I think. I'll come back to that. Hit that next here. Live demo, we get to test the strength of my Wi-Fi bandwidth here. All right, so here I'll choose, I'm now connected to the Azure APIs, and I'll choose some configurations of where I'm going to deploy to. And here we'll do a static placement. We can actually create the network resource group, virtual networks, all the solder blocks on your own. But if you have them existing and pre-configured, we can certainly take advantage of that as we do here. So we'll just select these options. All right, next. And now we'll configure our control plane and worker nodes. So we'll do, let's see, let's grab an appropriate sized VM here. How about for the control plane node, we can go a little small. Let's choose that one. I'll choose my favorite managed disk. And then here for the worker nodes, we'll go slightly larger. Let's go with some memory optimized, maybe 16 and 128. I'll choose some availability zones. Can deploy in a rolling manner. Here we can do the OS patching scheduled scans. So right out of the box, you can use we can do configuration, penetration, and conformance testing. And then once the cluster is deployed, and in fact across all clusters, we can do a software build materials to find any critical vulnerabilities that you may have. Of course, you could schedule your backups and pre-configure any namespaces or role-based access control here. So here I'll add a new binding, do a cluster admin, do add Martin in here. Then next, and now it'll go out and it'll look at those different components that are deployed. It'll look at the CPU and RAM and disk space that I've allocated, and it'll make sure that all those components are working well. Again, sorry, I'm tethered to my cell phone here. And now we'll finish configuration. So you can see all these have passed pre-flight validation, and this will go out and deploy a Kubernetes cluster in about maybe 25 to 30 minutes, depending upon the underlying hardware. So I mentioned earlier that we offer feature parity. We're very complementary to what you need to do in your new hypervisor solution compared to VMware and vCenter. So here it's a very similar interface you see. I have some virtual machines that are already deployed. I can just simply log in or click on a device, and it looks very similar to how you would see in vCenter. You can see now this is actually a VM running as a pod inside of Kubernetes. So you can actually see the YAML configuration. You can see the CPU. You can do traditional things like adding CPU, RAM, a live migration, a storage migration, take a snapshot. So a lot of the things that you can, in fact, open a virtual console. I think this is a video game, so you could actually play a video game. So a lot of those great features and functionalities that you're used to, you can get here with our solution. Okay.
Yeah, that's pretty awesome.
Here,
Jesse.
let me ask you, maybe I can show them quickly how to build a VM, or maybe we go right to your demonstration. You tell me.
Yeah, let's go right to the CloudCasa demonstration here for just a second, because I think we just want to make sure we're on time here. But when Jesse had deployed that VM in that cluster, he had actually made a pack or installed a pack with the CloudCasa agent installed on it. And from that, he would have been able to install our agent into his cluster to immediately prepare it for backup workflow. And so if we jump to CloudCasa here, this is
mind sharing? I have to share. Yep. I'll stop sharing.
Can you all see my screen?
Yep, we can see CloudCasa right now.
Okay, perfect. So this is a CloudCasa interface here, and this is where all the magic happens from a data protection migration perspective. But Jesse had given me access into his organization here. CloudCasa is a multi-tenanted application, so I can switch between organizations that I'm invited to. In this case, I have access to the Spectro Cloud organization and access to the resources, the backups and clusters that Jesse had provisioned there. And with regards to the backup workflow, he went ahead and installed some agents, some packs within his clusters that we can use for our demonstration purposes here. In this case, we have a cluster called VMO JBEN, which contains the underlying KubeVirt stack that's able to host those containerized VMs. So, users can have VMs on-prem. They decide that they want to access more compute from an Azure-based perspective, so they can migrate up those VMs. And this is all possible via cloud-native deployment and implementation. So if I drill down into this cluster that was created within this organization, I can see the cluster ID that was provisioned for that Spectro Cloud pack within Palette. And once the cluster is now marked as active, meaning we can inventory, look at all the components of the cluster, this is where we can define the backup of the entire cluster, or we can drill down, select individual namespaces, individual resource types, define how we want to make that copy. But in our case, we want to back up the VMs, right? So we have a VMO, virtual machine orchestrator, running within Spectro Cloud here. We can select VMs to back up, and here we can see those VMs that reside within that cluster. So here I have a VM residing in my default namespace called VMO Linux 1. I want to back that up, or let's say I want to migrate it. I can go ahead and confirm that selection here, and then choose how I would like to back that up, either by taking a local snapshot, local CSI snapshot on the storage, or I can copy that backup or that snapshot to an object storage location of my choosing. So that's if you're dealing with applications or storage that doesn't have CSI fully implemented, we can read directly from the underlying PVC or underlying host volume. So this is something that You're not limited to, if you don't have CSI snapshots available, we'll just read data directly from the PVC here as well. So once I have that source selection selected, I can add a policy for how I want to back up this VM, either a combination of hourly, daily, weekly schedules. I can also custom cron schedule it. I can safe lock the snapshot here as well to prevent other users from deleting the snapshot from my organization by enabling safe lock here. And so in my case, I'll just run it ad hoc. You give the backup job a name. We could call it backup VMO Linux 1 and do -2, and then just simply click create and run here. And that will resolve the VM down to the cluster, down to the underlying storage. Let me jump to my dashboard here, where I'll show you a backup has already completed for this VM. So I can look at my activity log. I can see what exactly happened. So we're backing up the custom resource definitions for the cluster. We're also backing up the persistent volumes, right, that are related to that VM here. And this is going to be an incremental forever backup. So we take one base backup, and then we're only backing up the change blocks. But here you can see that my VMO Linux 1 has been backed up successfully. So at this point, I can go and perform a restore of that VM, and that's just done by going to clusters restores here and defining a new restore. I've backed up my VMO JBen1 cluster here, so you can see that there's a catalog of all my recovery points listed here, and I can just select the recovery point that I want to restore or migrate this VM from, and click on next. And from this screen, I'm able to restore an individual file within the PVC. From a VM perspective, we'll be able to restore individual files within the virtual machine VM disk in our next release. So stay on the lookout for that. But in my case, if I just want to restore the full VM here, I can use our recovery point browser to select and drill down into the virtual machines that have been backed up. I see that my VMO Linux 1 machine has been backed up, and now I can define the destination where I want to restore that to, either back to the original cluster, or I can select a new cluster listed here. I can transform that restore by renaming the namespaces. Let's say I want to set a new name for that namespace that I'm restoring, or just simply add a custom prefix or postfix of a dash restored, let's say 0909. So that'll be the suffix that I automatically add to that custom namespace. And then from a storage class mapping perspective, if you are restoring to a different cluster, you know that those storage classes that might have been in the original cluster might not exist anymore, right? Or you want to restore to a completely different storage class, we can make that transformation here in our VM definitions or in our restore definition, as well as how we want that VM to behave when it comes up online, clearing the MAC addresses, if you want it to be powered on or off when it comes online. And that's basically it from a restore perspective. You have a post app hook restore that you can configure. This is just a post script that you can run after your backup completes. But you'll just give your restore job a name and select to run now. And I just ran a restore for right before this call started. I can see that restore has completed successfully here. And if I drill down into the activity log, I can see that it went about restoring the resources, restoring the VMs to its transform namespace. I can see the persistent volume details restored. So my VM is now in that restored state at this point. So if I jump to my Spectro Cloud, right, interface, my Palette interface here, I can go into the clusters that are listed here. I can take a look at the new namespace that I restored to. So this would have been default restored 0909. And I can see that VM has been restored with its, and is in that halted or stop state with its persistent volume claims already provisioned, and the data has been restored. So at this point, I can just drill down and start my VM, and that is my restore in a nutshell.
Outstanding. Thank you very much for walking through that. Very intuitive interface, if I don't mind saying so myself. And then
Much appreciated. Thank you.
I have one screen to share here. Hold on, or not video. Share screen. Entire screen. Share. And just one slide. Kind of a call to action. First and foremost, thank you very much for spending your day or part of your day here with us. We really appreciate it, whether you're watching live or on the recording. Please reach out to myself and Martin. Our details are there. You can find us on LinkedIn or our email address, or give us a call. And I believe if I was going to pick kind of some first documents to look at, it would be click on these links. I believe, Ant, we can get these links to the viewers after they sign up.
Absolutely. You don't have to reach through your screen, but yeah, I mean, what Jesse's got here on the slides, both products. There's plenty of details on our respective websites. CloudCasa has instant access. We in Spectro Cloud do not. But we've got some videos. We've got some customer stories, some data sheets. There's tons of material out there to add to this amazing demo you've heard today. I think what I've taken away from watching this is what a great better together story. If you are moving from VMs from VMware to Spectro Cloud, you've got the VMO feature. We also just deploy the CloudCasa agent into each cluster you create, and CloudCasa providing that VM-aware backup and restore, not just for Kubernetes, but for your VM workloads as well. It closes the loop, and I'm so glad you demonstrated a restore as well. The old saying, you go back 25, 30 years in backup. It's not a backup until you've tested that the restore works, which I guess was Jesse's problem back in the early days of his career, right?
Yeah. When you have 8,000 encrypted servers, how are you going to restore them? So good luck. You really have to put a lot of thought. Really have a lot of thought in how many servers you can restore at one time. And using a solution like a CloudCasa that is cloud-based, that can kind of eliminate your exposure, from everything on-prem being locked down, is, first and foremost, enterprise ready and ready to help you, whether it's Kubernetes or virtual machines. So. All right, so that's the end of our presentation. We have time for any questions, or
and I have a question here in the chat for you. Are you using CBT, changed block tracking, to create virtual full backups? Martin, I guess that's a question for you, sir.
Yeah, I'll have to look that up for you. I think it's some type of journaling like a CBT. I'm not sure if it's actually called CBT within Kubernetes, but we are tracking the change blocks within the PVC through the data movement and drivers provided to us by the CSI framework.
Fantastic. I don't have the name of the person who asked that question. I can see your organization. A great thing to do if you want to reach out directly to Martin and to Jesse. We can get you the answer to that question if you need any more technical details. Fantastic. That's the only question we've got in the chat right now. Guys, thank you so much for this presentation. It has been wonderful to see such a slick live demo. I really appreciate it. For those of you watching on the phone, please do sign in to our next webinar. We've got some really cool ones coming up for you, and look out for an email from us with links to some of these resources. Thank you very much. Have a great day.
Thank you.
Thanks, everyone.